And welcome guys to another video in our little FPS. Now today's video I stripped down to the bare minimum for damage arrows. Incoming damage that the player actually just basically gets hit from whenever people get shot or whatever. Well, the thing is, a lot of games have damage arrows. Well, in our game, we do not have those yet, and this will be part 1. Now, in this video, we're going to discuss what the problem is for damaging arrows in Unity when we have our base guide. One, if you see, this I just stripped down to basically pointing to the cube. It will always point in the cube in the editor because that's what I wanted currently right now. Now it works pretty good. You know, it freaks out when you get to like a really big angle, but it doesn't freak out in a way where players wouldn't know where to go. Okay? For rotation. It takes rotation and the actual position into account. So basically it'll work. Okay. But there's a few things that you have to remember. When you work with the UI system, you're working in screen space. This space right here that you see. Not this kind of space, which this is world space. From this to your cube is world space. So the problem with it is if you tried to get an angle or anything from here, when you try to translate it into world from world space coordinates, and you don't convert them over to screen space, it will just take this arrow and point it directly at them, and you won't see it because it'll be all weird and stuff. Okay? Now, there's a few functions built into Unity to do that, but you actually have to know that's your problem. So let's go look at a little bit of code. Okay? And here is basically it. Okay? Collections, we don't need this junk. Don't need that. Don't need that. Now, it's pretty simple. That's why I said I stripped it down to the bare minimum. Okay? For damaging arrows. We will be going over this and integrating it into health and stuff. But at first, we got to know how it works. Okay? And you won't have this in update either. You will have probably a coroutine that'll take the transforms right here, and you'll just flat do something with it. Okay? And then probably have destruction. But like I said, I stripped it down to the very bare minimal that you'll need. The execute and edit mode is just for executing in edit mode. So every single time I move something or do something, it'll run an update, and that's how the editor works. Start, I don't do anything because I don't really need it in this script. Okay. We have our arrow transform, which is just a flat image. This comes in the standard assets. If you download them, I just used a regular sprite like this. And when I get this and everything, it's actually backwards. Okay? So what you do about that, if your sprite is ever backwards, a lot of times you can just do the negative of it. Yeah, do the negative of it. And sometimes if you don't use this image right here and you actually use a sprite, then you got the option to flip. okay, a y-axis or so. But that's totally a different subject because that works in just 2D space instead of the canvas. I don't know if this method would work if you use a straight up sprite. It probably wouldn't act right. So I'm going to say this only works using a canvas in this method. If you were using the on GUI, it will probably work as well. You just have to do something else about your image. You know, you draw it on screen and then, but there's a angle function in there anyway. So I just negatived it because it was backwards on the Y. Pretty simple, and it's just a regular sprite. Promise you nothing special. It's given to us by Unity, you know, in the standard assets. And that's all that I did to get the arrow. Okay. We have just, you know, nothing here that does anything. This rotation's only here because the script is manipulating it. If I go in here and not have it execute in edit mode, like so, after it gets done compiling, I can zero this z-axis out. And yep. Come on. You're done compiling, what? There. So now it no longer does its base thing. So here's the thing. We've got a pointer, which is a vector. We need, I put this pointer in here because I'm translating it using MathF and 10.2. I think that's called. It's a funny word that I never use hardly any. But we take this vector3.direction and we go from camera.main.world to screen space. This is what I was talking about, going from the cube world space units to screen space. So I'm translating it from this junk right here, which is 3D space, to the 2D junk. Okay? Which, you know, how else could I explain it? You know? So this gives us our 2D space. Okay? So now I'm pointing Z using MathF and 10.2, arrow.transform.position. Now these are world units. Okay, when you're using position like this, it's the world space. Okay, and minusing direction.y because we went from world units to screen space and it works just fine. Okay, now it would probably work really, really funky if I do something like this. Local position, okay, because it's relative to a parent, which the parent might, you know, not exactly be what we want. Don't know what it would do, but it would probably not work. That's what I would be suspecting on that one. Then we're minusing. Anytime you're doing a lot of comparison, you're minusing one transform to another. A lot of times, if you do vector3.distance, if you do angles and stuff, you usually minus your target and then come up with a difference. Okay, so we're taking the position and the direction and minusing both of their y. Now the reason why I've got these curly braces in here is the way it executes. These curly brackets, in order for this entire function to run, it has to go in here and execute this first, come up with a number, this first, come up with a number, then it does the total and then returns it to the pointing.z. Okay. Now, this is very, very important to do it because we want the results from these two things to be used here. Okay. We need to subtract both of them. Now, I could probably do it up here somewhere and everything else, but the curly braces do what they need to be done. Okay, then I'm timing it by mathf.radians to degrees minus 90. Because we're working in 2D space, and secondly, Unity uses, I believe, a left-hand coordinate system. So a lot of times, this negative 90 is used because it's flopped 90 degrees. Every single time it just flops to 90 degrees. So you have to subtract. That's one reason why we have problems when we convert from Blender files and drag them in. They're flopped over on their side because everybody uses their own coordinate system. So it becomes a problem, dealing with that. So a lot of times we have to do offsets and stuff like that in our code to correct that. Now, since we've got the pointing.z now, and pointing is, a member variable, we had to do something with the arrow, right? We had to visually put it on the screen. Now, I don't do any lerping or anything like that. I just set Euler angles, which is quaternion. And the reason why I do quaternion.Euler is because this returns a quaternion, which an arrow.transform.rotation is a quaternion. Now, if you don't know what quaternion is, it's rotational stuff. It deals with X, Y, Z, and I believe it's B or no, it's W. No, it's W. There's something. Is that Unreal that does B? But anyway, whole lot of magic happening because of this function doing stuff for us. But there's no interpolation, so there's no smoothing. It just directly does it on the screen, forcing it. So it takes like a single frame and you'll never see it turning. I mean, imagine a picture, okay? And you want to stamp a fist bump on it, right? Well, you'll never see it go from a clear picture to a fist bump. It's just bam, done. That's it. And that's what the update would do for us. No interpolation, but we don't really care because doing it on a visual draw frame, okay? One single frame, and then the next frame, if it's different, then it just draws a different one, okay? You could see it visually turning, but in actual reality, it's just a single frame, like an image. I hope that makes sense to you. But this is the stripped down. This will give you a pointing. Basically, these two lines are just straight up just for getting the rotation you need for the screen. Okay? If you wanted to know and point an arrow at a certain point in the screen, or just anywhere in general, that will do it right there. Okay? If you wanted to do a damage text, that will be another tutorial entirely. But a lot of the code right here for problem solving that will probably most likely be here. Okay? So this is damaging arrows. Okay? Part 1. And the next one will probably be a while because I've got live streams for tower defense and everything. But this will give you the baseline for what you need. Okay? It will give you what you need for damaging arrows, the baseline code. How you integrate it into your damaging scripts and stuff like that, that's the only difference that you're going to ever see. And if you notice that this is a little off, like a tiny bit, it's because it's going for the center of the cube, okay? The center of the cube is always what it targets, alright? Because that's the origin point, okay? That's very important. So, I just want to say, peace out, everybody. Thanks for watching. I hope this helps you with your damage infliction or whatever you want to call your damaging little screen arrow thingy. The graphic really doesn't matter. You just have to make sure that your arrow is centered or however you want to design it. It really does not matter as much as you think. But you should do very well in your shooting, and in the next few videos for tutorials, I think I'm going to do maybe like hit scan on the screen. If you hit something that's player or whatnot, it puts a little X. But I think you guys will be able to handle that anyway. So peace out, guys. Take care, and I hope this helps you. Part 2 will sometime happen, but it's not going to be probably for a week, most likely. Or maybe I just get like lots and lots of requests, and then I'll probably do it a lot sooner. But thanks for watching, guys, and peace out.